SAS demonstration Proc report. In this demonstration, we are going to be looking at the procedure Proc report and look at the different types of reports that SAS can produce from that procedure. The data set we are going to be using for this demonstration is a data set on blood information from 1,000 participants. And so we have for each participant a subject number, their gender, their blood type, age group, white blood cell count, red blood cell count, and cholesterol. And so I'm creating a temporary SAS data set called blood. And notice I'm using an option here that we haven't seen before called trunk over. And trunk over is used when reading data with column or formatted input, and some of the data lines are shorter than the others. So the trunk over option is very similar to the miss over option. So the first thing I'm going to do with this program, I'm creating some labels, and then I'm going to use the basic procedures that we have been using throughout this class. I'm going to print out the first 20 observations for gender, blood, and cholesterol, and then I'm going to look at a Proc means of cholesterol, and then I'm going to look at frequencies for gender and blood type. And that will give us a feel for what this data set is like. So we'll go ahead and run all of this code. So first of all, the results of our Proc print, which shows our 20 observations, we see the gender, blood type, and cholesterol level. And notice that for quite a few of the subjects, cholesterol is missing. Then we have our mean cholesterol level for the 795 participants who had cholesterol values. And then we see the distribution of gender and the distribution of blood type. And we have complete data on gender and complete data on blood type for all 1,000 participants. Now Proc report looks a lot like Proc print. One of the big differences is that the statement columns is used to replace the var statement. And so we're going to start with a very simple report, a basic report I'm calling Table 1. And I'm only going to print out the first 20 observations. So again, very similar to what we did with Proc print. And notice I have the option NOWD, which is an instruction so that we don't enter into the interactive Windows editor after running this procedure. So let's run the Proc report and see what the output looks like. So here is the output from Proc report. We have our title, Table 1, Basic Report, and we have the columns gender, blood type, and cholesterol. And notice that the full name cholesterol wasn't included on the top of the column label here. So what are some differences in this output from Proc report compared to Proc print? So let's scroll back up and look quickly at Proc print. So here was our output from Proc print, and here was our output down here from Proc report. Notice that there is no observation column. There's no obs column. Also, the variable labels are automatically used instead of the column names. So you don't need a label option as you do in Proc print. And the column headers are adjusted to the column width. Now here we'll have to change the width of cholesterol so it fits the full header here. So those are some of the differences when we're doing just a basic Proc report compared to Proc print. Now let's embellish our table. So we're going to do some different things. We're going to add some labels and we're going to group our data. So in this example, a define statement is used to add a label for the column and to define the variable blood and gender as grouping variables. This means the results will be displayed in groups based on each category of gender and blood type. Blood type will be nested within gender. If we reverse the two in the column statement, then gender would be nested within blood type. Again, by default, Proc report produces detailed reports for character variables and summary reports for numeric variables. So you're going to see that cholesterol is shown as a sum within the grouping of gender and blood type. So here's the code. Our column statement indicates the variables we are using in Proc report. And then we have 3 defined statements for each of our variables, which gives our headings, and also tells SAS that we want to have this report with blood and gender as grouping variables. So let's take a look at what the output looks like. So here in Table 2, we are labeling the columns and nesting variables within group. So we have blood type within gender. And here for cholesterol, by default, SAS is just summing up the cholesterol levels for each subject in that particular group. So for females of blood type A, the sum of all their cholesterol values is 30,414. So that's not very meaningful. We're going to have to fix that because this report doesn't make a whole lot of sense. Also notice we've still got a problem with our column width, and so we're going to have to learn how to adjust the width so that the full name cholesterol appears as a column heading. So in this next bit of code, I want to fix the width of the column. I want to use the keyword mean so we get the mean cholesterol level within group instead of the sum. Here I'm making a width of 15, which makes our column wide enough for cholesterol. I'm using the format 6.2 to make the number 6 units wide, including the decimal point, with 2 digits reported to the right of the decimal point. So basically I'm not changing the code overall, I'm just adding that I want the mean cholesterol level, the width of this column being 15, and I want to format cholesterol with a 6.2 format. So let's see how the report looks now that we've modified it. This looks a lot better. Finally, we have cholesterol fitting as the column heading, and we have mean cholesterol levels for each blood type within gender. So this is a report that makes sense. Proc report also allows you to add other keywords. So you could include the median, the minimum, the max, the standard deviation are all available, and there are other keywords if you look under Proc report that you'll find. You can list more than one keyword, but that needs to be done in the column statement. So if you want more than one keyword, and notice you have a comma, and then those are the keywords that you want for cholesterol. So instead of having mean under the define of cholesterol, we now have the keywords in the column statement. So again, the code is very, very similar. The only difference is we basically have added standard deviation. So here we have now 2 columns under cholesterol. We have the mean cholesterol level and the standard deviation for cholesterol. Okay, so how can we make our table more attractive? The headline option puts an underline between the column headings and the data. The head skip option puts a blank line between the table heading and the first row of data. And finally, with spacing equals 2, this option puts 2 spaces between each of the columns, making the table easier to read. Then the break after statement with the skip option adds a blank line after each of the blood type categories. So again, we're just trying to make the table more attractive, and these options, headline, head skip, and spacing, all go with the Proc report statement. So let's see what table 5 looks like. Again, we're doing the exact same report, we're just trying to make the table look a little prettier. So here you see our table with more spacing. We've underlined our column headings. We've added spacing between each of the categories. And we've also spaced the columns. Now the last thing I want to show you is the compute statement. This statement allows the creation of new variables using a compute block. So you start with a compute statement and end with the keyword encomp. Within the block, you can have assignment statements, if then else statements, and do loops. Both the new variable and the new variable we're creating is a grouping variable for cholesterol called cholgroup, and the variable used to compute it are both listed in the column statement. The define option display is an instruction to produce a detailed listing of all observations. So here we see a lot more code than we've seen before, so we'll go through it. We're creating table 6, showing how we create a new variable col group. So our column statement includes all of the variables that are on our data set that we're interested in having in this report, plus the new variable we're creating within Proc report called col group. And then we're defining subject with a label subject. We're defining blood and gender, and this is all that we've done before. And we're defining col, displaying it as cholesterol with a width of 15. And then to create our new variable col group, we're listing the option computed. So this tells SAS that this is going to be a new variable that's created right within Proc report. And it's followed by the statements: if col equals missing, then col group equals blank. So this is going to be a character variable. Else if col is less than or equal to 200, then col group equals normal. Else if col is greater than 200, then col group equals high. And then we end this group of statements with our end cop statement, and then we have run. So let's take a look at this report and how it appears with this new variable that we've created. So here you see we have our new table, and in this table we're not doing a summary, we're printing out observations. Each observation is being printed. So we have the subject number, that person's gender, her blood type, her cholesterol level, and whether her cholesterol level is considered high or normal. And we're showing it for all 1,000 subjects. And notice that if a subject is missing for cholesterol, then that subject will not have a cholesterol group variable computed. And notice here that our col group has a proper label of cholesterol dichotomized. So let's go back and take a look at the code again. So see here, when we defined col group, we said it was computed, we gave it a label, and we also gave the label a width. So a couple of things I want to point out. Both the new variable col group and the variable used to compute it are both listed in the column statement. If you don't want the original variable in your report, use no print when you define col. So in the define statement for col, if you didn't want it printed in your report, you would just use the no print option. Use display when you define col so that individual cholesterol values are printed. So here we had this display here, and that's how we got each observation's cholesterol value. Use computed in your define statement for your new variable. So again, I use that keyword computed in the define statement for col group to tell SAS that I was computing a new variable. And then we use the compute and encom statements to create a compute block. And that's where we define our new variable. And finally, the variable col group is not put on the temporary SAS dataset blood. That variable is only there when we're running the Proc report procedure. It's not going on the dataset. We can't use this variable in another procedure. This completes the SAS demonstration on Proc report.